Okay. Yep. So thanks very much, and I'm very happy they gave us this big room and the nice chairs. So in this segment, we'll talk about consumer engagement. Now, it's always exciting to have our customers. In this case, Baystate Health is actually telling their journey in this, and not only really just we're not talking about technology, but more about this very important perspective from their health system around how to engage consumers better. And of course, the technology angle we have is around the Iris NLP technology. So you'll hear a little bit more a little bit later on also. So we have Ken Riley, who's the director at Baystate Health, and Joe Cafone. I'm doing this order. And he is a senior analyst at Baystate Health. And Benjamin DeBolt, he changed from his Formula E uniform, and he's the product manager for many of the product on the data platform team as well. I'm a physician executive. So today we'll talk a little bit more about really have Baystate describe their consumer engagement strategy, the theories behind it, which is very fascinating content. I hope you'll enjoy it. And of course, there is a specific technology that they deployed, which is the consumer portal and a patient portal in this case. And Joe will describe, maybe give you a little bit more details about the NLP project and the work that they have done, the results, and so on and so forth. And also, very interestingly, we also did additional work, and which Benjamin will give you a quick overview about Iris NLP, and the more interestingly is related to the HCC, or risk adjustment factor, some of the project that we're doing experiment with. And this is considered what I call, according to Jess, it's an exploration. That's what we're focusing on. So I think you'll find it very exciting to hear about these detailed topics. And without further ado, I'm going to pass it over to Ken.
Great. Thank you. Appreciate that. Let's see here. Okay, that must be it. Appreciate being here. Definitely the opportunity to articulate what we're doing over in Western Massachusetts. Can you hear me? No. All right. I don't know how to turn it up.
No, our AV guy's going to work it out.
Okay.
Yeah.
Thanks.
I trust him.
But we're from Baystate Health, and we're located in Western Massachusetts. Got about 850,000 residents in that area. Baystate Health has been around for 140 years, providing care to patients in that particular region. Over the last 5 years, 10 years, things have really changed, right? Patients have become consumers. They have choice. They're no longer just receiving services. They have options. And when patients have options, the paradigm has changed, and the organization needs to have a new way to attract and keep people in their organization. So things like loyalty, things like leakage, they become really, really important. Not to mention, when you don't necessarily have geographical restraints any longer, you can have software companies that take your business and not even in Western Massachusetts. So in order to kind of address that, we came up with a consumer strategy. Started with that consumer strategy in 2020. Let's see here. Right on. And it was a 5-year plan. The 5-year plan basically has us implementing systems that our patients can interact with, whether or not it's an interactive patient care system in the hospital, whether or not it's a consumer framework for people to engage with outside the community, but it's based on giving patients data and digital access and easing frictions that they may have dealing with the health system. Consumer insights are things that we got from psychosegmentation. HealthShare and Salesforce are things that are going to enable our OATH, which is orchestrated access to care. Service excellence is journey maps and whatnot. And chatbots and symptom checkers help with our digital foundation. Understanding the needs of our patients, not only through surveys and family advocacy groups, but through the digital footprints is key. And that's basically what we're doing at this point, is mapping our patients' digital footprints through this consumer strategy. This one's interesting, I have to say, because when I first started looking at all of the natural language processing that was out there, NLP was really the first thing that was there, but it has become broader now. So this concept of natural language technology offers us significant opportunities to improve operations, opportunities to improve services, and the most immediate use case is NLP. Being able to articulate and being able to work through customer feedback and find interesting ways for us to personalize care along with the consumer strategy is basically what we're trying to do with the NLP project. We have lots of places where our patients are able to engage, and they give us text, whether or not that's secure messages to providers, whether or not that's them interacting with the Get Well network system in the hospital itself, whether or not that's emails that are sent back and forth. But there's a lot of this unstructured content that we get from our patients where there is insight to be had, and NLP is something that we're leveraging in order to give us what we need. We put the hype cycle in there because, frankly, it's nice to see that we're at this slope of enlightenment, and we're at a place where we'll finally be able to see some sort of results from the NLT technology. These are the three main use cases that we see right now. Intelligent document processing, conversational AI, and insight engines. They're the use cases that are prominent at this point. IDP is something that we'll talk about later on. Insight engines are expensive at this point, but some of the core services that we get from the Iris NLP product gives us things like text summarization and text classification. Things like knowing if it's an email, that's a type of classification. Things like knowing exactly where the messages need to go if we're talking about secure messages from our patients. A lot of the foundational services that we have come directly from the code itself that's being implemented. This is an example of our insight engine, and basically on the left you have all of the sources that I kind of alluded to in the beginning, right? So we have all of these customer-facing applications and platforms to include our CRM, to include our interactive patient care systems, frankly our telephone system hooked in and providing us voice to text is another input for our insight engines. And again, the Iris NLP offers us slivers of those components that make up an NLT engine, which is super expensive. We couldn't necessarily afford an NLT engine all by ourselves, but we could use components that come from the NLP Iris product and allow us to get to a place where we're actually able to categorize messages and provide insight from those messages from our patients. This particular slide we wanted to show because it was an experiment that we did back in 2018 and 2019. And essentially what we did was use the categorization of our patients to create special messages to them to increase their interactions with our patient portal. And ultimately, we discovered that it was possible to create behavior change, and it was possible to create sustained behavior change, because when we went back and looked in 2022, all of those individuals that had increased secure messages, they had increased and stayed increased as far as how many times that they are messaging their providers. So basically what we discovered was that there was an insight for categorizing the messages that our patients have and basically looking forward to how we can pull out relevant meaning from those messages. So with that, I'll pass it over to Joe, because basically what we've done is we've taken those messages and we've gone one step further. And so now we've started to try to triage those messages and whatnot.
Yeah. Thanks, Ken.
Yeah.
I first want to thank these guys on the ends. They really empowered us to just do. And I initially wanted to just ask a question and poll you guys of who has personal community, but it's okay. If you have it, you need to just start doing what we're going to show you here. Just jump in. There's no benchmark or expectation, but the whole beauty of this is that we're looking at the third best source of data, right? So first is talking to the patient directly. And the second is on the phone with the patient. You can hear their inflections and understand. This is the third. This is them reaching out to us with a need, a question, whatever it is. And what better opportunity to just start looking for insights where we weren't looking before. I mean, it's real time. We have this stuff coming in all day long. And so I know is here. It's right. It's enabled in Iris. It's just whether you turn it on and start using it or not. But I would encourage you to go back home and start doing that. What did I want to say? So let's go into what we did, right? So yesterday in the fireside chat, Rebecca Ollinger said, patients think that the providers are reading their messages right away. And that is not the case at Baystate right off the bat. The messages go into pools, and they're triaged by the front office staff at each of the practices, for the most part. And every day, there's about 750 messages that go to these practices. And that's messages. So that's in personal community, you can select general messages or medical messages. And that's separate from, I want to request an appointment or I need my prescription refilled. Those are a completely separate process. They come through as messages in a separate stream. So as soon as we plugged the state into iKnow, within minutes, our assumptions were disproven, right? Like minutes. And that's why I'm telling you guys, go back and just do it, because you have these assumptions about how your data is being used, and then you find out that maybe there's some action you can take that'll make the patient experience better, right? Save time by prioritizing the messages when they come in, as opposed to having the front office read the messages chronologically as they're going through. Like, put the ones that need to be addressed first. So if you can't read the slides, don't read the slides. It's not important. You'll see this in iKnow. This is just giving some context to what I'm going to talk about. But this is the iKnow interface, right? And it's if you think it's overwhelming, it's not. It's just very wizard-like, and you set it up, and you have your data source on the back end, and you point to it and say, this is what I want to do to it, and these are the parameters I want you to have as dimensions, and this is the data source, and you can put your stop words in, and those are sitting over in the corner. So anyway, they're all highlighted there. So 1 is some initial settings on the full data. 2 is you find your parameters that you want to have as dimensions. 3 is the data source. 4 is where you put your stop words in. And then 5 is you compile it, and then you build this thing, and then you can go into looking at it. So here's the output, right? So I'll skip to the numbers and make it even easier for you. So again, you don't have to read them, but the point is, like, if you can read this, this is good. So these are general messages. This is just a subset of our messages that we looked at, and it's the general messages. So these are messages, I just want to talk to my doctor about something. And if you can look, the first most popular term in this data set is appointment. And we're finding that patients are literally sending a general message to their doctors asking for appointments when they can ask for appointments in the appointment thing. So they're just doing everything from any message interface. They think, and what we're assuming is, they think they're talking to the provider in these messages. So they're reaching out and saying, here's what I want done. And so we need to start addressing it that way. When they're looking for stuff that's urgent, we need to make it urgent. And so this exercise that we went through told us we got to really rethink and add some prioritization to stuff that we've been passively just pushing along.
And also, right, one of the things, because we're in the process of redesigning our patient portal, and so just with that, we recognize that we don't need categories for the questions. Patients just want to ask a question. They don't care about general whatever else. They're just going to ask a question. So one of the things that we've done is eliminated that and just have the ability to ask a question. And we wouldn't really have figured that out. It's anecdotal, but once we saw it here, that they were just using whichever channel for whatever they wanted, it allowed us to simplify things. And ultimately, that increases the engagement, right? We make it so that people actually want to ask us questions as opposed to trying to filter through all of the different categories.
Right, and as our team is essentially, so who listened to Jeff's presentation this morning, we're like the incubator group, right? We are idea factories, and we're trying to push concepts out and empower this health system. So we want to start doing things like this, and we need to do it easy. And this is just one of those opportunities. I'm glad he stopped me, because I wanted to just talk to these 4 points quickly. So one, what I was saying, in section labeled 1, that's the terms, the main terms. And then in the section 2, those are the similar stems. So things that are related to the top stems over on the left-hand side. And then number 3 is the proximity. So these are terms that occur around those terms. So when you select appointment, those are the terms that come around. And then you can see, of course, schedule and reschedule are literally sitting right there as the top two. And then 4, I just wanted to point out that these are general questions. And so this is the first question in a slew of back and forth. I didn't look at all the replies and things that happen. This is just when the patient initiates the conversation, this is what's happening. And so next step is, okay, what can we start to tell? What stories can we start to pull out? And I know gives you this interface to start looking at some examples. And so I actually searched for now today, right? So I was like, oh, that's a fun term to discuss, right? So when you do that, if you look down the bottom of this screen, you can see that now today's are, they're highlighted orange here, but they're also orange on there. Ben has some really wonderful stuff that does things where colors they mean things. They draw your eye to it, right? So you have the negations in red, and you can see how they occur around the terms, and it's wonderful for sniff tests. This is just some this is some in-depth examples to just start the conversation about. And so what happened next was we wanted to scale this out. And so I shouted to Ben and I said, Ben, I need a way to pull all of this out and look at it in aggregate. And he's like, okay, this is very easy to do. So we created these tables. And so if you look on the left-hand side of the screen, you create a schema from your model that I know creates, and it creates all the relation tables. And you can build SQL. So if you have any SQL experience or any developers, they put this SQL model together, and you can create really awesome tables. So if you look down the bottom, if you can't see it, no big deal, but it took our raw data, and then it applied the stemming, and it told you the keywords, along with the dimensions I had added in the beginning. So now I have this data set that I can put anywhere and run some analytics on or run some visualizations on. And so that's what we did. So I just pulled this out, threw it in Tableau. Not a big deal, but it gives us another way to interact. And I think that's what everybody wants anyway. Like, let me handle my data the way I'm comfortable handling it. And they're already doing that too. Like, that's the Python thing they're talking about. That's what we do at Baystate is we work in Python. Notebooks all day long. And so this is just an extra freedom. And so if you take nothing away from whatever the 10 minutes I talked, I don't think I taught 10 minutes, but whatever, it's go back and just start messing around with it and start this conversation of, well, what is our data really doing? And with that,
just add on. So some of this external utilization. We're a Tableau shop, so we're grateful for the ability to, extract it and be able to upload it so that we could share it with other people out there. It's really helpful. And then, we do have an academic wing of the hospital that's interested in learning more about, behaviors and the psychologies of our patients. So doing things like word clusters and seeing commonalities in some of the segmentations that we have is the next thing that we're looking at, right? It's possible to understand someone's personality and psychology from their digital footprint, right? All of the tools that they use in the hospital, that basically creates a model that then we can leverage. And the more data points that we have in that model, the better we can actually provide an experience that's personalized for those patients. And I know the ability to export it into Tableau gives us the visualization to be able to look at what we're seeing so that in the end, again, the best way to understand what our patients want is to ask them patient-family advisory groups, surveys, and those type of things. But we can't do that for everyone always. But what we can do is monitor their usage of all of the patient technologies that are out there, have that stuff assessed, assimilated, aggregated, so that we can pull out meaningful insights out of it. So there's lots of stuff that we can do with it, and there's lots of stuff that we plan on doing with it. But being able to pull it out of I know certainly propels us in that direction. It's nice.
There you go, Ben.
Thank you. And let me please also allow me to thank you for picking up this technology with such enthusiasm. It's been really great working with you. So
cool.
So I won't make this too long. I'll give a quick update of what we've been up to in the last year or two with InterSystems Iris NLP, which is sort of the name for how we embedded the I know engine in InterSystems Iris. And I'll also talk briefly about a project that we're running right now, and present some of the results of that one. So I also very much like the way how you're illustrating the native and open approach that Jeff talked about earlier this morning. So we've got a native NLP engine that's part of the Iris platform, and we have queries and we have some interfaces that you can use to browse the data, but it's also open, and you're by just pointing Tableau at those table projections is really a great illustration of the openness of this technology. So. When you were presenting the slide with the insight engines, that was a great illustration of the breadth of natural language technology. There's really a lot to it, and there's many different tasks, many different types of activities and functions in this broader area. And INO solves one of those, a sliver, as you put it. It's really not an engine that covers all needs, that you can just ask a question like Siri. The goal of INO is to extract concepts and their context from natural language text. So we look for concepts. We look for the word groups that belong together. So not just an individual word, but things that, because of their role in the sentence, because of their position in the grammar of the sentence, that are actually one whole thing. So that, and we do this in a very efficient way, so that it doesn't require upfront dictionaries, etc., to get going and to begin with. And we do that by exploiting patterns in the language. And we do that for 11 languages these days. So what you see on the right-hand side is sort of a rendering of the output of those concepts and the relationships that link them together. And then also context annotations, such as the one in purple is when we recognize that there's a measurement expression. Red is when we find a negation, which is very important, of course, when parsing healthcare information, and then also date information, sentiment information are all things that we can identify, and not just the keywords. We're not just identifying the no in a sentence, but we're expanding that annotation left and right based on our understanding of the language and the grammar that defines it. So that's what INO does. What have we been up to in the past year? So as you may know from Virtual Summit 2020, that's when we presented the open source version of our technology. So the core engine is available as a Python library. So that allows you to process documents one by one and get information in sort of a machine readable version of this out. And that is a valuable Python library. We've got a customer that's actively using it and contributing to the project by providing us with feedback and challenges that we can react through the GitHub repository that has the open source code. But what we've done over the past year is strengthening that, making sure that those engine capabilities are up to scratch and that they match the robustness of the embedded version of the technology. And also that you can interoperate, that you can kind of take the open source flavor of it, and if you're experimenting with that and making changes to the language models, that you can take advantage of them in Iris. Because the embedded version of the product, of course, has the ability to also store the output and then provide you the kind of table projections and things that Joe was using. A second thing that we've been spending quite a bit of time on is are those semantic attributes. So I mentioned negation, sentiment, etc. So we've added certainty in the past year, and also offer generic attributes that some of our customers are using creatively, for example, to model family history, which in certain circumstances we can also detect and annotate. We've added and improved Swedish and Czech in the past 2 years. And extended our attribute support across languages, because we always start with the English language model and then gradually expand that to others. So next to this very brief overview of the product, I also wanted to talk a little bit about a really nice project that we've been running with help and advice from Joe and Ken, and together with Chi and also with the team back in Belgium and in Cambridge. So the goal of this project is to use NLP for risk adjustment. Risk adjustment, and it's actually better to explain this with the next slide. So if you're the reimbursements that, or as a provider, as a healthcare provider, that you the funding that you can receive is based on how you bill your patients. And the idea is that if you just go for the obvious facts, where you're only, for example, in this, and you have to read this table sort of left to right. So say we're kind of assigning billing codes only based on the demographics. So we know the age of our patients, we know that they're eligible for Medicaid, and kind of that's it. That gives us an amount, a reimbursement amount that you see in the circle on the bottom left corner. If we are able, with information from the claims data, to also assign basic conditions such as diabetes and vascular disease, we can get a higher risk adjustment score, a risk adjustment factor. That's the RAF acronym in there. But if we really go and look through the patient chart, if we're really going into the detailed notes for that patient, we can tune it and we can find that this patient doesn't just have diabetes, but there are specific comorbidities or specific complications, or there's another comorbidity that's somewhere mentioned in the text, but that wasn't explicitly billed in the claims data. And you can see that number at the bottom right in the green circle is much, much higher than what's on the left-hand side. So this is the motivation for this project, to see if by leveraging NLP to speed up the work of those chart reviewers, if we can help these organizations be more efficient and generate better revenue streams. So how did we approach this? We've sort of combined qualitative approaches with purely quantitative work. So the data set that we were using was data for about 7,500 patients, and the challenge with such a data set is that if you're throwing, this is natural language data, so it's super varied. If you're familiar with machine learning techniques for NLP, you'll realize that 7,500 really is nothing. So that's why a purely quantitative approach is not good enough, or is not going to work. It's not going to give you enough signal in that data set. So that's why we leveraged our skills for qualitative analysis to build and improve rules based on the text. So just some numbers. So that kind of complement the slide, the chart we saw earlier. There is a very significant number, a fraction of the population where there's missed coding opportunities, where we actually could have achieved a higher risk adjustment factor and get better funding for our organization. And as you can see, risk adjustment factors can typically be improved by 16%, and especially very common comorbidities like diabetes are miscoded or undercoded, whereas they actually make a difference and can lead to better efficiencies. So briefly, some of the findings of how far we got this far. So there is a challenge that was on 2 slides ago. One of the challenges of this project is that the data that we have was data for these patients, clinical data coming from Health Insight, and then claims data from Baystate Health for those patients for the year 2019. So if you're using machine learning, if you want to have an accuracy score of your model, of your approach, precision and recall, you got to know the truth. You got to know what you're measuring against. So the question is the claims data correct? And are you going to try and prove that it is correct? But then if you're building such a model that tries to prove that assumes that what we have in the claims data is correct and complete, then it's unlikely that we'll be finding a lot of missed coding opportunities, because we're actually trying to improve the claims data and find missed opportunities. So that lack of what is called a gold standard, a full complete training set, has been kind of challenging, and is actually encouraging us to make sure that we use this, that we combine quantitative and qualitative approaches. So what you see in this chart is that as the result of kind of the assumption for, or let's say the combination of that qualitative approach, and then lining up what the claims data says and what the NLP model says for a specific HCC, hierarchical coding condition coding, sorry.
Yeah,
the acronym
hierarchical clinical classification. Yeah.
Thank you. For artificial opening. So those are common factual things after you've had an operation or a procedure that are often missed that are often undercoded. So so the total data set is about, as I said, 7,500 records. And as you can see, the claims data says that there's 49 cases where we have an ICD code, an ICD-10 billing code that corresponds to this artificial opening fact. So that's what we're going to try and predict. So what we did, or what we first found, is that our NLP model that we built through qualitative modeling of rules is that in 36 cases we agreed, or our model agreed with the facts from the claims data. When our NLP model was negative, so those are missed cases by the NLP model, we actually found out, manually reviewing these 13 patients, that 30% of those cases were miscoded. So actually these are patients for which the ICD-10 codes are apparently not correct, or for which at least there was no evidence in the text that they were correct. So maybe it was based on other structured information that is not included in our analysis, but those are cases that were worth exploring. But the more interesting cases are the cases where our NLP model thought that we could apply the HCC 188 code, and it wasn't present in the claims data. So after manual review, we found that half of those cases really were eligible for this code. So that is a very interesting number, because it is a significant opportunity for generating more revenue. In the remaining data, that is both negative for the NLP rules and the HCC 188 rules, there's likely going to be some dark number of cases that both approaches are missing, but it is not cost efficient to also review those in as much detail. So we didn't pursue that as much. So that's more or less what we've done thus far. I think this proves that there's the current approach suggests that there's definitely an opportunity for higher risk adjustment factors. It will differ a little bit from HCC code to HCC code, but we do believe that there's absolutely a value in pursuing this. We're on a journey, so we're not tapping into all of the information that is available, or all of the things that Iris NLP has to offer, what the INO engine has to offer. We have yet to add the semantic attributes such as negation. We also need to find ways, tooling is going to be a part of that, to scale up the rules building work. And then finally, to take this to a product level, obviously we would need to make sure that this becomes available in an easy-to-use interface, so that the chart reviewers have an easy time and can get contextualized, highlighted evidence of what we found in the text. And with that, I'll happily open it up to questions. If you would, please raise your hand, and then Jim will bring the mic to you.
I'm really interested in, can you share some insights which you got out of the NLP feature, which decided you guys to do things differently, maybe?
Are you referring to like when we were reviewing our messages?
Yeah.
Okay, so there were a few. It basically all boils down to prioritizing messages in a method better than medical first and then go chronological. That's default, right? That's how they're coming in now. The nurse assistants or the MAs in the front office say, okay, let's handle all the medical questions first, and we'll take the earliest one and just get through it. But now there's opportunities here to say, this person needs to reschedule their appointment. This person is feeling worse than they did yesterday when they reached out to us, and you see those trends. Now today was one of those examples where it's like, I did all this yesterday, now today it's worse, or now today I can't whatever. And so, and INO does a great job of pointing that out. And because it's pointing it out to me reviewing, those can be pretty straightforward keyword tags. And so I think an opportunity here is, because you have to know, this is all within the health share ecosystem. We're not taking stuff out to do any of this processing. This is all being made aware to us within it. So it would be wonderful as a next step to say, let's just throw those tags either in the subject line or file them into different folders. So now instead of the MAs in the beginning, looking in the medical folder and going chronological and then the general, how about urgent folder or appointment-related folder or symptom-related folder? And they go through those, and it's guiding, and it gives them a priority they didn't have before.
It's very much like the emails, right? I mean, you set up your rules so that it goes into your junk folder and goes into whatever else. I mean, that's ultimately what we're talking about. And so when we take, I mean, we have over 1 million messages, and you pull them into the system and have it filter it through, it actually provides us a lot more efficiencies than you might think, because you know, right now, I'm sure any of you that work in health systems, you know that we're all drowning in these messages that are coming from our patients, right? I mean, with COVID and whatnot, that was the primary mechanism for people to communicate, and there just aren't enough staff on the inside to answer those messages in an efficient manner, you know, as soon as the patients want that stuff. And so to be able to put them into categories so that we can use our limited resources more efficiently has been effective. And you know, ultimately, you know, there's other ideas out there as far as where there might be blobs of text that we can pull that insight from, right? So you know, I mentioned an interactive patient care system, but we've got these smart screens in front of all of our patients in the rooms, and the patients can put in goals, care plans. They have families that have access to this outside of the health system that could put information in, and being able to extract meaning out of that text is what I'm looking at doing with I Know, right? Is basically hitting all of those data sources that we have. When we get Salesforce, which is something that we're in the process of implementing now, right? That's another huge source of textual information that we're going to have from our consumers that we want to have some sort of meaning behind. So, and like I said in the beginning there, right? The idea that patients want to have categories for their messages, we blew that right out of the water in the first 5 minutes. And you know, we kind of thought that was the case, but that showed it to us immediately, because I mean, you could see what patients were doing, and that is a major design decision, because that certainly simplified a lot of things on our side. But we did have to go to the business and tell them, okay, well, you know, you're going to have an MA or somebody that's going to filter all of these things, because frankly, the patients don't want to do it and they're not doing it anyway. So it just shifted where the burden was, but at least we could increase the experience that we had for our patients. This whole remote patient monitoring thing that is moving forward as well, I mean, this is big stuff, and patients are communicating what they're doing and how they're feeling, and we don't have enough physicians to manage it all, right? Managing by exception is kind of the standard that we're moving towards, and being able to glean insights from texts that are coming in from our patients, and being able to manage just things that are kind of anomalous, as opposed to checking with every single patient, is the only way that we're going to be able to survive. And so these type of technologies really help us do that work well.
So I'll just add in one of Ken's slide, and there's a way to profile the patients, and I actually didn't even realize there's a method that they're adopting, and it's from a company called Patient Bond. It was just fascinating, and there are these 5 or 6 categories of patients, and you classify them into, and for example, in this case, there's a self-achiever. You know, goal-oriented, they always do, they exercise like crazy, kind of like me, and but at the same time, there's also willful endurer. And they all like behave differently. So as an organization, provider organization, you don't treat them the same. And how do you profile them? Assuming they can go online, do a test, that's one thing, but if there are any ways to infer what type of patient are you based on the communication style, and a lot of stuff that you can do. So leveraging all these signals from the patient to profile them, just so that you use different strategy to approach them and to make it easier for them. I think all this are hopefully can turn into something additional that not only help you triage, but also really decide what type of channels and kind of service offering that you want to give to these patients. So to me, I'm super excited about you know, the more we understand the patient, the better we can serve them. Any question on the risk adjustment? That was a common pain point we heard from the ACOs and also the insurance companies. They're really wanting to use these technology to help with the revenue aspects of it. Any questions on those at all? No? All right, I think this is good. So we got 3 minutes left, and this is excellent. So thank you again, and really appreciate you coming here and participating in this presentation. Thank you. Yeah. Thank you.